Hello, brief calculus students. I got asked about this question, average rate of change, which is not the same as a limit, although we're getting close to a limit. But we just want to know how it's changing, and eventually we're going to call this average rate of change a derivative because we're going to get smaller and smaller so that it becomes an instantaneous rate of change. But right now, I'm going to show you how to do this function using technology where we've got an interval that we're looking at. And I have made a video with your calculator. Move the screen, that light's in my way. But I'm going to show you Excel. So here's the function, and here's the point, and here is h. Now the formula for average rate of change looks a little complicated. So let me move this up. Okay, basically, you'd have an extra little bar in there. Okay. You take the function out of, the input, it's like you're finding a slope of a line. You're going to have a change of x on the bottom and a change of x on the top. We often write this with a delta. This is a Greek letter that looks like a little triangle. So the change of the function, so this is what this is. Change is just subtraction. How did it change? And then divided by, and this is where, how in the world did you just get h? Well, what's on the bottom is this point, a plus h minus a. So that's why we just get h, because h is just the amount of the change. And you can see that h is going to get smaller and smaller and go down to what we call instantaneous. So I put in the function. I'll need a couple parentheses. I don't need a parenthesis yet. So the function itself is 4 divided by, and then we put in a, which is 5, plus h. So there's the first piece. We went over just a little bit, and then we're going to subtract exactly what is 4 divided by 5. And then, let's see, so I've got the whole thing in parentheses. See how Excel gives me enough parentheses, I know. And then I'm going to divide it by h. And the reason I like using Excel is because there's the click and drag. So as I click on this cell, which has, and I'm going to move the screen over, which has the function in there, but you see, I had clicked on cells. If I move this little cursor over to the very corner, bottom right corner, notice how the cursor changed from a fat plus to a really skinny plus? I just click on that, hold the mouse down, and drag down. That's called click and drag. And so if I come to this one, so the first one was G, and then 4 is the, let me go ahead and get rid of these columns. I'll just delete them. There. So you can see. Alright. So this one should now be C4. Let's see. C4. Let me just see. Yep, it's C4. Excel it's just a location. The next one is C5. The next one is C6. So this is how Excel is really good. Now I looked at this and I said, what is 4 divided by 5? Because, we've been taking limits. We've been getting close to this value. And it is not the same. Look, it's negative. And it's a smaller number. What's going on? Well, let me go ahead and graph this for you. So I'll just put in some x's. And then some 4 divided by x. So I guess we shouldn't start with 0. So let's go 1, 2, 3, and then since it's got a pattern, I can just click and drag. Equals 4 divided by this number. Enter. So So right there you see where the 5 is. And I'm going to graph this. So let me move this up. Okay, I would like to insert right here, recommended charts. That's what I need. Oh, what did it just do? Okay, come on, I'm just trying to move this over. Recommended charts, let's try this one. Yeah, just kind of like a scatter plot. Okay, so I'll move the picture down again. Alright. Actually, maybe I should connect this. Let's see. Wow. Okay. Let me just go ahead and delete that and try it again. So I hit insert. So I hit insert and I come over here, recommended charts. Let's get the screen over again. Okay, dotted. Let's go ahead and put some lines in. Okay. So as we're coming close here to 5, you can see that it is going, the slope of the line is negative. And as we move closer and closer, let me go ahead and I'm just going to insert a straight stick. So that should be a shape. Okay. So here's a straight stick. Okay, there's 5. Although we were looking bigger than it, weren't we? Okay, so let me move my stick. Okay, so it went through that point. Nope, move you around. Okay. So the first point was what happens when you get from 6 to 5. Oh boy. You can see, I'll just go ahead and stretch this out. You see this line has a slope. That's the average rate of change. And as we get closer and closer to these points, the line actually becomes what we call a tangent to it. So it's just touching at one dot. I'm going to make this line a little bit bigger. Wait. Okay. Oh. And maybe orange. Ooh. Red. Wait. 2. Okay. So it just touches at one dot. And that's what we call our instantaneous rate of change rather than average rate of change. But that's what we're doing. We're getting closer and closer. So instead of right here at the... Oh, that's at 4. I wasn't even paying attention. Sorry about that. Okay. Come here to 5. So as we come from 6 closer and closer, in this case we're coming from the right. So if we were taking a limit of the average rate of change, we'd be coming from the right. We can also come from the left. So let me go ahead and get rid of this. Oh, come on. Bye-bye. Okay, what happens if we were coming from the left? So let me make that -1. Negative 0.1. Negative 0.01. Negative 0.001. And negative 0.0001. Look, it's coming, and this was from the left because it's from the negative side. We're coming up with the same answer, so we know that the limit is going to come to negative 0.16, which is the slope of the tangent line. It's also the instantaneous rate of change rather than the average rate of change, because that's what we're zooming in on. And that is going to be what we call a derivative at a point. And that's an important part of calculus. So I hope this helps with that problem. And I'll send out the other video as well. So I hope this helps.